All right, so now we're wanting to find the slope of the tangent to y equals root x. So I want the general slope at any point where x is equal to a. So I'm going to find the derivative of this function. So my derivative is going to be the limit as h approaches 0, square root of x plus h. Sorry, we're letting our x value be a. So a plus h minus root a all over h. And so if I want to plug in h, I get 0 over 0. That doesn't work. Looking at this, something that I can do is multiply by the conjugate. Normally I do that when it's in the denominator, but since I don't really know what else to do, I can try it here. So a plus h plus root a. I'm going to have to do that on the top and bottom. A plus h plus root a. That's going to leave me with a plus h, and then minus a, which is great, over h, times root a plus h plus root a. Still haven't evaluated my limit. As you can tell, this is something that's hard for me to remember to write every time. All right. So my a's are going to cancel, my h's are going to cancel. I'm going to end up with the limit of h going to 0 of 1 over root a plus h plus root a, which gives me, once I evaluate, 1 over 2 root a. So this tells me that I can find the slope of the square root function at any point a by evaluating 1 over 2 root a. So let's think about that. If I come in and graph this, so I'm going to graph the square root of x. Whoops. So y equals square root of x. I'm going to clear this out. I know that this graph really only exists in quadrant 1, so I'm going to change my window and go from 0 to 10 and also 0 to 10. So here's my square root function. So really what I'm thinking is that, for example, when x equals 6, here's my slope. It's pretty flat. So when x equals 6, it looks like, according to this, so at x equals 6, the derivative, or the slope of the tangent, should be 1 over 2 root 6. Calc. Derivative, x equals 6. And we get this value. If I calculate 1 divided by 2 root 6, then I can see that I have the same value.